welcome to yet another video, and in this video we're going to talk about the determinant of a 2 by 2 matrix. And my name is KenMath, and if it's the first time to be on my channel, please don't forget to subscribe and hit the notification bell. Okay, so we're talking about the determinant of a 2 by 2 matrix. So how do we find the determinant of a 2 by 2 matrix? We are still talking about matrices. So how do we find the determinant of a 2 by 2 matrix? So for example, if you have been given a matrix which is A and then equals, which is this matrix, they have said A here and then B and C and D. So this is a matrix that you have been given. How can you find the determinant of this matrix? So we can find the determinant of this matrix by doing the following. So number one, you have to multiply the elements in the major diagonal. So number one, multiply the elements which are in the major diagonal, which is this diagonal here. That's the major diagonal. Or let me put it in this way. So this is the major diagonal. So you multiply the elements which are in the major diagonal, and also you multiply the elements which are in the minor diagonal. And then when you multiply these two elements, the product of the major diagonal, you have to subtract from the product of the minor diagonal. What do I mean? What I mean is that we're finding the determinant of A. So say the determinant of A, the determinant of A is equal to, which is the major diagonal, the product in the major diagonal, so A multiplied by D, and then we subtract C multiplied by B. So C multiplied by B or B multiplied by C. So that's what we do. So this is the product of the major diagonal, and then take away the product of the minor diagonal. So this is how we find the determinant of a given matrix. So for example, let me give an example. So a practical example, for example, we have been given so I'll say example. So we have been given, for example, number one, we have been given matrix A, which has got 2, let's say 2 here, and then elements 2, 0 and 1 and 1. So these are the elements, and then they say find, so I'll say A, so the determinant of A. This is what it means. So to find the determinant of A, we are going to do the same procedure, which is the determinant of the major diagonal. We multiply the product of the major diagonal, take away the product of the minor diagonal. So that's what we're going to do. So we're going to say the determinant of A is equal to, so 2 multiplied by 1, which gives us 2 times, or multiplied by 1, and then this is the major diagonal, and then okay, so 2 multiplied by 1, the major diagonal, and then take away, which is 0 multiplied by 1, which is the minor diagonal. So 0 multiplied by 1, which is the minor diagonal, so it gives us it's equal to, so 2 multiplied by 1, it gives us a 2, minus 0 times 1, it gives us a 0. So it will give us A, the determinant of A is equal to this, take away 0, it gives us a 2. So that is the determinant. So that is how we find the determinant of a given matrix. So that's how we find the determinant of a given matrix. So remember, the matrix that you are going to be given, or the matrix that you have been given, is a 2 by 2 matrix. So that is why we are saying the determinant of a 2 by 2 matrix. So that's the determinant of a 2 by 2 matrix. Example number 2, which is example number 2, we are going to be given a B is equal to, so B is equal to, we have got determinant, we have got elements, those elements. So these are the elements or entries. So for B, 2, 3, -4, and 8. So the determinant B is equal to, of B is equal to, so 2 times 8, so the major diagonal, 2 times 8, and then take away the minor diagonal, which is 3 times, or multiply by 4. So 3 multiplied by 4, and then we say the determinant of B is equal to, so 2 times that 8, it is 16, then minus 3 times -4, it will give us -12. So that's one. And then we'll say the determinant, so the determinant of B is equal to negative multiplied by negative is positive, so 16 plus 12. So we'll say negative multiplied by negative is positive, and then we say 16 plus 12, it will give us 28. So the determinant will give us a 28. That's how we usually find the determinant. Okay, apart from these scenarios, let's talk about other scenarios. So we talk about other scenario. So we say, which is number 3, they'll say given that which is a matrix A will be equal to 1, and then -1 here, and then 2, and then x, like that. And then they will say write an expression in terms of x for the determinant of A. So we'll say write an expression in terms of x for the determinant of A. So we are writing an expression. So write an expression in terms of x, for the determinant of A. So we are writing an expression. So first of all, if we write the formula, which is when finding the determinant, so say the determinant. So we say the determinant of A is equal to, so open bracket, 1 times 2, or 1 multiplied by 2, minus -1 multiplied by x. So, and then we'll say this, we'll say 1 times 1 multiplied by 2, it gives us a 2, minus -1 multiplied by x, it will give us a negative x, we close. And then we say we'll say negative and positive. Now negative and negative, it's positive. So it will be 2 plus x. So 2 plus x. That will be the answer. This is an expression in terms of x. So this is an expression which is the determinant of a is that. So the determinant of a is that. And then the other question which can come from here, they can say find, after we have found the expression, so find the value, find the value, this is value, the value of x, find the value of x given find the value of x given the determinant, given the determinant, given the determinant of a is 5. So they have given us the determinant of a is 5. So we have to find the value of x. So how can we find the value of x? We're going to find the value of x. We have already found the expression is already written. So this is an expression. This is a 2 by 2 matrix. So this is an expression which is written here. So this expression, it's already written as the determinant of a is equal to 2 plus x. So where there is a determinant of a, they have said given the determinant of a is 5. So given that the determinant of a is equal to 5, so we have to find the expression. We have to find the value of x. So we're going to say 5, which is where there is a determinant of a is equal to 5 is equal to 2 plus x. So this is an expression that we have already made. And then from there, we're going to group the like terms. So we're going to say 5, and then it will be minus because this is the positive. When it crosses this sign, which is an equal sign, changes to minus. So minus 2 equals x. And then from there, we are going to say x will be equal to 5 take away 2, it will give us 3. So the value of x is equal to 3. Let's prove if it's correct. If we put 3 here, where there is x, we put 3. So we'll say negative 1 multiplied by 3, it will give us negative 3. And then 2 times 1, it will give us 2. And then minus 3. So negative and negative, positive. So it will be 2 plus 3. So 2 plus 3, it gives us a 5. So it gives us a 5. So which simply means that it's correct. This is the 5, the determinant here. So that's how we usually find the determinant. So that's how we find the determinant. So for more content, don't forget to subscribe to my YouTube channel, for more content. And then the other thing is that when you find the determinant, the other thing that you're supposed to know that there is what we call a singular matrix. There is what we call a singular matrix. So singular matrix. So singular matrix. So this singular matrix, a singular matrix is one which has the determinant of 0. So if you find that the determinant of that particular matrix is equal to 0, then it's what we call a singular matrix. So if you find that the determinant of that matrix is equal to 0, then it is a singular matrix. That's what it is. So that's how we usually call it. It's a singular matrix because the determinant is equal to 0. Simply means that it doesn't have a determinant. And then when a matrix doesn't have a determinant, simply means it has got no inverse. So it has got no inverse because it doesn't have a determinant, which is a 0. For example, you have been given that, let's say 2 here, and then 3, and then let's say 3 here, and then 2 here. You have been given those as entries. So we'll say the determinant of A is equal to, so major diagonal take out minor diagonal, so 2 times 3 minus 3 multiplied by 2. So say the determinant of A is equal to 2 times 3, it gives us 6, take away 2 times 3, it gives us 6. So which gives us the determinant of A is equal to 6, take away 6, it will give us 0. So the determinant of A, it gives us 0. So it simply means that this matrix is a singular matrix. So it's a singular matrix. Why? It's because the determinant is what? 0. So it's a singular matrix, meaning it doesn't have an inverse. So a singular matrix does not have an inverse. That's what we call a singular matrix. Thank you for watching this video, and don't forget to subscribe to my YouTube channel, and don't forget to like and hit the notification bell so that you receive all the contents that I'll be, if this content is helpful, you're going to receive all the contents that I'll be posting.